Swayam Prabha. Digital India. Educated India.
Welcome to the course Environmental Impact Assessment. Today we will look at the state of fresh water, which is an essential element for us. So accordingly, our coverage will include, we'll look into the importance of fresh water, we will look at different pressures on fresh water and especially due to climate change. Further, we'll look into water and land use, and then we'll look into global state and trends, what are there regarding fresh water. Particularly, we'll look into water quantity, water withdrawal rates, we'll look at the glacial retreat, water scarcity. Further, we'll look into water quality. How do we really, what are the determinants in which at which we look at. So we'll look at the pathogens issues, nutrients, sediments, and so on. Further, we'll look into freshwater ecosystems, like what is happening with the freshwater ecosystem, the loss of wetlands, biodiversity loss, and then impact on human health and other areas. So the expected learning outcomes, which is expected from you after you complete this particular session, that you should be able to synthesize the significance of fresh water while undertaking EIA. So when you look at EIA, you should have a conceptual understanding about where you are locating yourself in the entire context. You should be able to discuss the issue of climate change and fresh water. Further, you should be able to review the relationship between water and land use. You should be able to connect local problems with the global state and trends of fresh water, which you're going to see today. You should be able to identify different water quality related issues and parameters and support them with case examples and facts, which we are going to see. Further, you should be able to discuss the state and its use of freshwater ecosystems. So let us first think of the importance of fresh water. It is essential for our health, our well-being, essential for animals, plants, and for both aquatic and terrestrial ecosystems. Its importance has been recognized in Sustainable Development Goals. Review, think how many SDGs concerns with water, and further many of the SDGs apart from these which are directly connected with water will not be achievable without availability of fresh water. So water is one of the very important, fresh water is one of the very important part of the entire SDG. So we see that SDG 2 that deals with food security, SDG 3 that deals with health and well-being. So you can see number of SDGs which are directly connected with water. So now moving on, we see what kind of pressure is there on fresh water. There is considerable pressure on fresh water due to climate change. We see that the global water cycle, which is the most important component of weather and climate system, is changing. In the image, you can see the global hydrological fluxes and storages. Here it is expressed in 1000 kilometer cube per year. How much water storage is there in the boxes you can see in the diagram. You can see the natural and anthropogenic cycles used for domestic, irrigation, industry, and so on. So you can read this diagram and see how the water flows. And the major concern is that this cycle is becoming faster due to our warming planet. You may also be aware that fresh water available as surface water in rivers, lakes, and wetlands is limited. It's just 0.4%. And you may note that the fresh water is decreasing in a very fast rate. So we see that the cycle is also increasing, as well as there is decrease in the freshwater also. You may also be noticing around you that there's increased floods and droughts. You have also heard of loss of glaciers. All these changes cause direct and indirect impacts on our health and the health of the ecosystem. For example, as stated, nearly 1.7 million people die annually from very preventable disease, diarrhea. And we see in India, as per Intensified Diarrhea Control Fortnight IDCF guidelines 2019 by Ministry of Health and Family Welfare, we see that childhood diarrhea diseases continue to be a major killer among under 5 children in many states, contributing to the 10% of under 5 deaths in the country. So we're looking at 10% is just happening by this. Around 1 lakh children die due to diarrhea annually in the country. So that's the death rate we're looking at. Diarrhea deaths are usually clustered in summer and monsoon months, and the worst affected are children from poor socio-economic situations. There are a range of factors that influence freshwater quantity and quality in different regions. The condition worsens due to uneven distribution of fresh water. So we see that there is uneven distribution of fresh water. Some areas have lesser water and some have in abundance. People migrating from one place to the another, from rural to the urban, and over and above, we now have increasing events of extreme droughts, floods and storms. So these all influence the availability of fresh water quantity as well as quality. We are also witnessing reduction in the resilience of the ecosystem because of natural and human-made disasters. So in addition to that, we are experiencing disasters along with unsustainable use of fresh water and related ecosystems. So we're also noticing increase in salinization. So there's also, apart from this, there's also salinization happening due to the global warming, as well as land use changes, melting ice and snow reserves, and then also pumping of groundwater, and then drying of continents and rising sea levels. So all these are again influencing the quality of water. We are also noticing change in precipitation, with many areas now receive less precipitation or they face drought than in the past. Whereas many other experience more rainfall and temperature than before. So we are seeing this variation happening. Major concern is that fast warming of the polar regions and high mountain region creating unpredictable situations. So now we have a situation where we are not able to predict. So we further see that in this situation, there's a contrasting situation. There's evidence of increasing drought severity in Europe, with historical record indicating increased aridity over many areas since 1950s. So what happens when there is too much rain? It causes pollution. Whenever too much rain happens, we see increase in pollution, we see soil erosion, we see avalanches, mudslides, and together, all of these together can cause floods, tornadoes and cyclones. So leading to another disaster. These would further cause physical damage to our infrastructure, cause loss of life and injury. And looking at what really happens when we have little rainfall. So when we have little rainfall, it causes drought, extreme wildfires, sandstorms, soil degradation and increased competitions over water sources. So we start, there's conflict for what water sources we have, and this often leads to accelerated shrinkage and loss of these goods. So we consume it very fast, and then these sources what we have start shrinking. So very well known example of this shrinking water body is the Lake Chad you can see in the image here. And then we have example of Aral Sea, the disappearing wetlands of Islamic Republic of Iran, Lake Armenia and Iraqi marshes. Then you can also think of the Caspian Sea. The videos of these have been given to you in the suggested reading and watch. You can further see their documentaries to understand what's really going on. So global climate change also interacts with weather and local scale climate effects, as well as the unsustainable water uses and diversion, leading to dramatic impacts such as shrinking freshwater bodies. So we see that what's really going on. So you can see those cases there as well. Collectively, these realities and risk have grave, very severe socio-political, economic, environmental and ecological implications. So if such kind of things happen, see all other dimension it influences, making better management and governance of freshwater resource an imperative. So it becomes very, very essential for us to look into it. So now moving on, we'll look into water and land use and how they are interconnected. So water and land use, we also see that because of urbanization and agriculture intensification. So we are going on witnessing rapid urbanization, and then we are also changing land use for the agriculture purpose because we need food. There's issue about food security. We are changing the land use, and eventually both surface water and aquifers are depleting. We are reducing those quantity. For the purpose, we are also seeing wetlands are being drained. Further, we see that many rivers, lakes and ponds are disappearing in water scarce regions. So we are also seeing completely disappearance of rivers, lakes and ponds. So despite the environmental significance and associated support services, as we see that wetlands has lot of value, wetlands have been subjected to degradation for past many decades. So we are going on losing them, and the condition is deteriorating. As we can see in these images, the present situation of wetlands in North India as they continue to suffer. So there are other interconnected problems also which we see because of the land use change. The surface hardening happens of the natural areas which reduce infiltration and limits the aquifer recharge. So all the aquifer we have, it limits their recharge as well. At the same time, increase water runoff and pollution. So when we have increased water runoff, pollution, we again face other kinds of problems. So poor land quality and loss of forest leads to increased runoff, carrying eroded sediments through rivers into oceans. So we also start damaging the ocean and the rivers. So large scale deforestation is also increasing the chances of reduced precipitation and increase in soil erosion. So as and when we are going on changing the land use, we are using cutting more of forest, then we are increasing the chances of reduced precipitation, less of rainfall. So that also increases the chances of soil erosion. We may note, as per the report, major parts of the withdrawn water, what we are drawing water, is used in agriculture. Though agriculture doesn't come in the purview of EIA, but you need to know that major water goes into agriculture in the range of 70%. There is always conflict of water usage between agriculture and industry and energy production. So we see that they all are demanding for water, and water demand for energy, and if you'll see, the water demand for energy is much for the purpose of non-consumption, such as for cooling of the structure, the mechanism and so on. So a lot of water goes in that. The interconnections between water, energy and security and food security have identified tensions. So because all of these need water, and there is trade-offs between them. It requires very careful considerations and looking into the matter. This nexus becomes especially important when considering drivers such as urbanization, population, economic growth, technology, and innovation. So one needs to really look very careful into it. And when you do EIA, and then how any kind of development, how it is changing or how it's influencing these conditions. Now let us look at the global state and trends of fresh water. So we'll be looking at the trends now and the state, the facts, certain facts here. So first, looking at the state of water quantity. In the global hydrological map here, you can see how aquifers and groundwater sources are unevenly distributed, like we also talked before, that we really the water sources are unevenly distributed across. Look at the dark blue color indicating major groundwater basin in India. You can see dark blue color over the Himalayan region, so that region is rich in the water resource. Green color shows the complex hydrological structure. Local and shallow aquifer shown in brown. Dark and light blue polygons with brown boundary are the surface water. Reflect how they are distributed and what kind of conflict and challenges it poses. So you can look at the diagram here. So we further see that groundwater is the major drinking water source, and it's major drinking water source for majority of people at the global level. Particularly it is in the arid regions and during the drought. So one really uses groundwater heavily across the globe. So it is the estimated available renewable groundwater resource in Africa is said to be more than 100 times that of total annual renewable surface water resource, but using that deep aquifer water is constrained by the exploration as well as the cost which is involved. And if you're familiar with the water condition in Africa, you would know that water is there, but still it cannot be accessed, or it's expensive to be accessed. It's unsustainable to access that water. I've also provided you a link to a video where you can learn more about the issue here in Africa about the water resource, groundwater resource. So moving on now, we'll be looking at water withdrawals rate. So in the following image, we see global trends in increasing groundwater use, so shown in light green box and line. Look at the increase in the groundwater usage in India and other countries. Water demands varies across geographies and contexts such as urban or the rural areas. So how do we really consume water varies culturally as per the geography, also as per the context also. Most of the water is used by agriculture, as we mentioned before as well, and it consumes 70% of it. So you can see the global trend of increasing groundwater. So groundwater use has plateaued, so there is certain level of stabilization in some regions, but is increasing elsewhere. So you can see India here, such as in Asia and Pacific and West Asia. About 2/3 of the fresh water utilized in West Asia, and about 75% of European Union inhabitants rely on groundwater for drinking. And groundwater use compared with the surface water has increased substantially in the rate of 1.3 trillion meter cube per year across North America. So it's been extracted very heavily. So we further see that UNEP report, 2012 report, suggests that it is because of increased agriculture groundwater usage that has caused increase in depletion rates in major aquifers. So because of this, major aquifers are getting impacted in arid and semi-arid zones. We are mining some of the large aquifers in an unsustainable manner by exceeding their long-term natural recharge rates. So all aquifers have their recharging rates, so we have been exceeding those rates. Further, we see that the problem, particularly fact, if you look at 5 of the world's 7 largest aquifers are in Asia and the Pacific and are overstressed. So they have been used extensively. It is also reported that because of excessive groundwater abstraction, there is also sinking of the land area in coastal cities, such as we can see in Bangkok, Ho Chi Minh City, Jakarta, Manila, we can see. So I've provided you a link for that. You can see the image here of Bangkok, how the sinking of the city is taking place. And other cities you can see from the suggested watch and readings. Overexploitation of an aquifer can also impact wetland ecosystems. So once we overexploit aquifer, it can also impact wetland ecosystem. Hydraulic fracturing for like all the resources like oil and gas extraction, they also like impact the groundwater. So access to groundwater may be further limited to the climate change impact due to the rise in sea level. So as and when sea level is also rising due to climate change, it's further increasing the problem of access to water, groundwater. Most of the islands are experiencing increasing freshwater shortages. So that's also happening. Now looking at the problem of glacial retreat. So we're going to now look at what's glacial retreat. Because of the climate change, there is impact on the availability of water in the region around the world. In particular, areas which are dependent on the melted water of the glacier. So a lot of our area is dependent on glacial water. For example, Hindu Kush Himalayas, as you can see in the image here, this region is largely dependent on the melting water from 10 river systems such as Ammu Darya, Brahmaputra, Ganga, Indus, Irrawaddy, and so on. You can see here as shown in blue lines and glacier shown in pink polygons. So you can see that how this river system and then the glacier, all that provides water for us. So Hindu Kush Himalayas provides water to 20% of the world's population. So it's a huge number what we are looking at, huge proportion what we are looking at here. In this image, you can see retreat of Calsacaya ice cap in Peru between 1988, what you can see in the left hand side, to the condition in 2010 in the right hand side. Note how the snow area is reducing. Pay attention to those areas at the edges. See the difference between the two. Studies show similar loss in tropical glaciers in Andes, in European Alps, also in Central Asian glaciers. Large population and ecosystem downstream depends on the available fresh water. So I have given you the link to all these documentaries which you can further, if you're interested, you can look at those. Now moving on, we'll try to understand water scarcity. Let us see what we mean by water scarcity. Water scarcity is defined as less than, when it's less than 1000 meter cube per capita of available renewable fresh water per year. So that is when we say water scarce. So and excessive withdrawals are often caused by water scarcity. So whenever we are excessively withdrawing, it's because there's less water. So there is also a term, so there's one term which is water scarcity, but then you'll familiarize yourself with another term which is economic water scarcity. It is used where storage, treatment and conveyance, like the how to store it, how to treat it and how to transport it, all those infrastructure are lacking. So that then, even though water is there but it cannot reach to the people, then we say it economic water scarcity. So lack of infrastructure combined with rapid population growth can lead to economic water scarcity, although there are debates on actual cause of water scarcity. So like what really causes water scarcity is debatable. In the image, you can see global, physical and economic water scarcity. So you can see the two here. The blue polygon indicates the physical water scarcity when we really say as per the definition what's the water scarcity, and the black polygon shows economic water scarcity. So you may note the difference here, and you may see in Indian context also how's the variation here. So water of appropriate volume and quality is not always available at the right time or in the right place for specific use. Water scarcity is common throughout West Asia and the Asia and the Pacific region, and in arid parts of Africa, like you had seen in the map, Latin America and Western United States of America and the Middle East. So it's like you can see it's widespread. Factors like what really causes water resource stress, we see that it's the large population, pressure of population, then the agriculture expansion as agriculture consumes most of the water, and the intensification, variation in the rainfall, how the rainfall is changing, and then we also see there's very fast development, and then increasing urbanization, industrialization, as well as climate change. So all of these cause water resource stress. Further, we see another problem, that's desertification. Desertification is a pressing problem in Africa's sub-Saharan region arising from climate change and internal migration. So that's also happening here. So you see a lot of desertification happening. In the parts of developed worlds, you see the desertification also happening in Europe, North America, Australia. Water scarcity is the challenge that is commonly addressed through large water infrastructure projects such as dams. In parts of the developed world, we see that in particular in Europe, North America, Australia, water scarcity is a challenge. So it's a problem that is commonly addressed through large water infrastructure projects. So there are a lot of water infrastructure projects coming up, such as dams, long distance pipeline and desalination plants. Given expected population growth trends, regions such as Middle East, Africa and Asia need to address water scarcity in innovative and scale appropriate ways, including water governance, rainwater harvesting and wastewater recycling, and they need to leapfrog the conventional solutions of the past, and they really need to have innovative solutions to handle this. So that was about the state and trends of fresh water. Now we'll look at concerns of the water quality. So looking at the main human activities, water quality is also influenced by natural system, but we are going to look at primarily at the human activities that influences the water quality, such as you have population growth, urbanization, agriculture expansion, transportation, and human and industrial waste. So you see that how it pollutes the water. So pollution, if you look at what pollution includes, it includes pathogens, nutrients, heavy metals, and organic chemicals. You can see in the snip of the table from the Global Environment Outlook. The table shows water contaminants and their sources. These pollutants come from point sources such as domestic, industrial or sewerage pipeline, discharge, septic tank leakages, or it can also come from non-point sources, so like land surface, runoff from extensive diffuse agriculture use and urban areas following rainfall and snow melt events. So it is reported that water quality of many lakes and reservoirs is particularly at the risk of extinction across the globe because of long water residence time. So water is very stable for quite some time, and its tendency to accumulate pollutants. So that's why we see that the lakes and reservoirs are at particular risk because it's stagnant water, and it has chances, pollutants have chances to settle in for longer time. So groundwater pollution sources include non-point agriculture and urban runoff, on-site wastewater treatment, oil and gas extraction and fracking activities, mining and industrial sources. So most of this comes under the purview of EIA. So you would be learning about that further, that how it's influencing our groundwater pollution and how you really need to evaluate that. So further, we see about the pathogens. So pathogens are major concerns causing waterborne diseases. Waterborne disease continue to be a major challenge in many African, Asian, Pacific and Latin American cities and rural communities. So you can review the scenario in the same table. You may note that parasites can survive water body conditions for many weeks. And viruses may survive drinking water treatment as well. So even if the water is treated, the viruses can survive that. So you may consider those things and see these from the facts here. Further, we see the nutrients. Let us familiarize ourselves with the term eutrophication. Eutrophication represents a natural aging process of lakes and wetlands, wherein they become enriched with nutrients. So it gets more of nutrients and sediments and becoming more biologically productive, usually over a long period. So because of our activities, the nutrients loads can drastically increase. What goes into the water, the nutrients would drastically increase, and this process accelerates, speeds up. Acceleration damages the whole ecosystem. So because of it getting rapid nutrients, it damages the whole ecosystem and eventually reduces its usability for our activities also. So it damages the ecosystem, at the same time it reduces its usability for our activities and affects our environment. So algal blooms can turn water body opaque and green in color, leading to reduction in water's oxygen content when algae die and undergo decomposition. So it also causes loss of oxygen, and when there's loss of oxygen, then it kills fish, life also in the water. Some blue-green algae species are toxic to fish and livestock and affects our health as well. Studies also indicate a clear relationship between climate change and eutrophication of lakes. So in the image you can see the dead zone, also called hypoxic zone, in the Gulf of Mexico because of nitrogen from Midwestern United States of America carried down the Mississippi River, which eventually decay of algae growth consuming oxygen in the water, and it has suffocated the marine life. So it's said to be the dead zone. Therefore, there are nearly 4 times as many dead zones in the ocean now as there were in 1950. So we are finding more and more dead zones in the ocean, including the Mediterranean Sea. So I've also provided you the link for additional watch if you are interested to see. In the image here you can see the model estimates of trends in the fecal coliform bacteria, which are the group of bacteria that are passed through the fecal excrements of humans, livestock and wildlife levels in rivers. And you can see the difference in 1990, 92 to 2008 and 10. Look at the red color, so you can see how is the spread of this. Now moving on, we will look at the other determinants of the pollutant. Here we see sediments. We we see the issue of sedimentation, which happens from erosion of exposed soil surfaces. These eroded soil get deposited in basin throughout the world. So it's happening throughout the world, including in Africa, Asia, and Latin America. Because of the land use change causing deforestation and unplanned settlements are major causes of soil vulnerability to erosion. So because we are continuously changing the land use and causing deforestation, there's a issue about unplanned settlements. So our soils are getting vulnerable to erosions, and storm generated runoff carries soil into the downstream water bodies. So we are also damaging the water bodies. In the image you can see the tailing sediment from Samarco Dam in Brazil. So you can see here. So you can further refer table for impact, causes and facts. You can see here the contaminants and their sources. Moving on, now we'll look at organic pollutants. Further looking at the organic pollutants such as liquid manure, sewage effluents and sewage treatment sludge and so on. Biodegradation of these when biodegradation happens, these deplete oxygen concentration. So whenever these organic pollutants are biodegraded, they deplete the oxygen concentration in the water bodies, and oxygen depletion leads to fish kills and higher biochemical oxygen demand, BOD. When there's high BOD from microbial decomposition, these pollutant causes release of heavy metals from bottom sediments back into the water column. So you see the kind of damage that happens. So studies based on the model analysis indicates BOD concentrations increased in many parts of Africa, Asia and the Pacific and Latin America during 1990-2010 because of the industrial and domestic wastewater discharge and agriculture and urban runoff, with highest increase in rapidly urbanizing and industrializing countries. So that's happening more in now urbanizing and industrializing countries. BOD pollution is most developed countries, has significantly reduced with the enhanced wastewater treatment systems. So we also see synthetic organic pollutants, which include pesticides, industrial chemicals and solvents, and personal care and pharmaceutical products. Then we also see persistent organic pollutants. POPs are particularly problematic because they do not readily biodegrade in the aquatic environment. And you may know that these are used by many industries and agricultural applications. They can impact human health, aquatic ecosystem, persisting in fatty tissues of human, fish and other organisms, and accumulating in sediments. So in the image you can see anthropogenic total phosphorus loading to lakes, 5 largest lakes by surface area in each of the 5 UN environment regions. So showing average percentage contribution in 2008 and 10 annual loads. You can see here, you can see how much loading is happening from manufacturing, agriculture, urban surface, runoff and so on. So pay attention to those legends and look at the colors, how it is distributed here. So moving on further, we see the pollutant heavy metals. We are also facing problem of heavy metal, which are used in industrial, agriculture sectors, water intensive mining and so on. They degrade the water. Concerns are serious in some Asian, Pacific and South America, African and Latin American countries. They also damage plants. Many like mercury, lead, chromium, cadmium are toxic to human and aquatic organisms. So groundwater pollution due to metals also has been reported to have occurred in Canada as well because of the tar sand industry. So industries also have a role to play here. We see that the natural arsenic groundwater contamination in South Asia and other countries in Asia and the Pacific, that's already there naturally, but that gets further aggravated with our activities of metal mining and groundwater abstraction. You may refer to the critical example of heavy metal contamination involved with the Flint, Michigan case, so where the source of water had to be changed. So now we'll look at another component of water quality, that's salinity. Salinity happens due to increase in quantity of dissolved minerals in fresh water from the land use change. So it happens because of the land use change, agricultural irrigation drainage, lake evaporation and seawater intrusion, sea level rise, water abstraction, so on. And if excess salinity happens, then it is unsuitable for human consumption. So we cannot consume it, and then many of the plants and organisms have limited tolerance to salinity. So salinity problems prevails in Africa, Asia and Pacific and Latin America and all this, and then and it has been increasing because of the industrial water uses. Saline water intrusion into coastal aquifers can result from over abstraction and mismanagement, as well as sea level rise. So salinity impacts the quality of environment and as well as impacts the food security. There are now many emerging contaminants. So you have seen certain of them, a few of them. Now there are many other emerging contaminants such as human and veterinary pharmaceuticals, personal care products, insect repellent, so what all stuff we use, you may look at that, and also microplastics and manufactured nanomaterials. So these all are new contaminants we are seeing. United States Geological Survey detected such contaminants in majority of sample streams in US. So you can see what's the level of contamination. In the image you can see the model estimates of trends in biochemical oxygen demand concentrates in river between 1990-92 to 2008-10. The red color streams indicate the increasing concerns. Scan through the image and see where all you see the red color streams. You can see here. So in the image you can see the source and pathways of pharmaceuticals and personal care products entering surface and groundwater. You can see here how it's happening, all the sources, how they are entering. Further, we see plastic waste is another major concern. Microplastic can contain and absorb toxic chemicals. Electronic waste is another concern which we see because of their widespread abundance. We have a lot of electronic waste and unknown risks to surface and groundwater quality. So we don't know what kind of impact it has. So if you further see, there are other groundwater quality concerns as well, which is important from EIA perspective. You'll see the groundwater pollution from oil and gas fracking activities, which are large quantities of chemicals and discharge large volumes of produced water. So that all gets into groundwater. And also the byproducts of all these activities, there are a range of products which also which happens during the operations are also of concerns. We further see lake acidification, thermal pollution, radionuclides are also problems here we see. Now we'll look at the freshwater ecosystem. So there is a continuing loss of wetland. So we are experiencing loss of wetland. Examples of freshwater ecosystem or inland wetland include marshes, swamp, peatland, wetland forest, rivers, lakes, ponds and headwaters. All these are examples of freshwater ecosystem, and they provide a range of functions. So there is it does a lot of things, such as it provides regulatory and supporting ecosystem services. We'll also see all these in the ecosystem services in the methods section where we study that. So in the image you can see the status and trends of the world's wetland and wetlands disaggregated by region, and you look at the dark green line indicates the trend in Asia. So you can see here how the wetlands are reducing, and pay attention to the dark green line here. So ecosystem services for all wetlands types have been valued. So it has, we'll also look at the valuing system. So it has been valued financially across, and the value of it ranges from $300 to nearly million USD per nearly 9 million USD per hectare per year. So you see the value which is there. Peatlands are very important as they have a high carbon sequestration value. As they have high carbon sequestration value, hence they contain more carbon than all global forest biomass combined. So you are seeing the image of the world's largest tropical peatland in Congo River Basin, containing an estimated 30 gigatons of carbon. So you can see here, I've also given you the link to further watch. You can see there are issues of draining the peatland worldwide in the past decade of changing land use. We are also witnessing biodiversity loss. Studies indicate loss of flora and fauna because we are losing all these, so that's also creating that. Wetlands do have the capacity to filter and improve water quality. However, beyond a certain point of like the tipping point, a wetland can no longer regenerate itself. We are also witnessing fragmentation of rivers while we are constructing dams. We are creating water diversion with resultant wetlands, habitat losses and degradation. So while we are fragmenting it, these all things are happening. This has significant impact. So dams and reservoirs for water storage and hydroelectric power are seen from different perspectives. So it has been used a lot, but at the same time the usages are also going down. In recent years, dam construction in industrialized countries has slowed considerably. Many older dams are being decommissioned for economic and environmental reasons. And dam remains highest in the industrialized countries. Dam density nevertheless remains highest in the industrialized countries. So now looking at the impact of problems in fresh water, it has impact on human health, causes gastrointestinal illness. Predicted change in hydrological cycle with climate change may increase the environmental health related disease. In the image you can see the morbidity from diarrheal disease of all ages for females. Pay attention to the red color as shown by through the study here. You look at the red color, the most severe areas. Then in the image you can see the morbidity from diarrheal disease for male. So you look the color difference, how it's different for men and women here. So it impacts the food security as well. So that also we see. And then furthermore, we see that human safety and security is also concerned. Degraded water quality, physical and economic water scarcity, and loss of freshwater ecosystem services have significant impact on human safety and security. So whenever floods happens, droughts happen, it affects large number of vulnerable people with security, and there's also migration implications. So that's all what we saw. So summarizing what we covered today, we discussed about the importance of fresh water. We looked into the climate change and fresh water. We looked at how the relationship between water and land use. Further, we also looked at the global state and trends of fresh water, like what's really happening, so that when you do EIA, you have a larger perspective of the environment. Then we identified different water quality related issues and parameters, and then we discussed the state and issues of freshwater ecosystem, and we also looked at the impact, what happens. So that's all for today, and this was our references, and our coverage has been limited as per the scope and of the subject. Additional resources to read and watch are provided to you. So you can look at all these suggested reading and watch here. Thank you.